Hi guys, and welcome to Connor's Math Lab. Today we'll be talking about compound interest. So first of all, what is compound interest? Well, say that you are investing $1,000 in a bank. That gives an interest of 10% per annum. And here, per annum simply means that the interest is yearly interest, which means that the 10% is 10% per year. If this were simple interest, after 1 year, you would get $1,100 because we have the original sum plus $100. After 2 years, we would have $1,200 because we would have the original sum plus 2 times $100, which equates to $1,200. After 3 years, you would have $1,300. And this would go so on. However, what about compound interest? Well, in compound interest, in the first year, you would still have $1,100 because it is 1,000 plus 100. But in the second year, you would now have $1,210. Note that in simple interest, we only had $1,200, but in here we have $10 more. Why? Because we would have the original sum from the first year, $1,100, plus 10% of $1,100, which is $110. Well, in here, we had 10% of the $1,000. So simply said, compound interest is just interest on interest. Instead of taking interest on the very original sum, we take interest on the new sum that was accumulated previously. But before we talk about any formulas in regards to compound interest, we have to get a few things straight. The first thing is vocabulary. The original amount is called the principal within the realm of money. And the second thing is that interest might not be compounded yearly. Interest might be compounded monthly. It might even be compounded daily. And usually in stock markets, it is compounded quarterly. Well, what would happen if this were compounded quarterly? After 2 years, it would not be $1,210 because instead of calculating the new amount every year, we would have to calculate the new amount every month. What do I mean? Well, after the first year, you would have 1,000 plus that 10% interest. But note that here, the interest is not 10%, it's now 100. Because this is 10% yearly interest, we have to divide that interest by 12. So 12% of that 1,000, which will yield you an amount of $1,008.3. And now this is your new principal. And after doing this 12 times, you would get your amount for your first year, which totals something like $1,104, which is a little more than $1,100. And this, in my video, I will call this the rate of compounding. Now, after I explain all this, we can get into the formulas regarding compound interest. Let's first start with the formula for yearly compounding interest. What do I do if I'm compounding interest yearly? Well, first of all, I have to start with the principal amount. And when I'm compounding interest yearly, let's say the interest rate is R. I would have to multiply this by 1 plus R. Note that in here, R is the interest rate, and P is the principal. But if I only multiply P by 1 plus R once, this would be interest after 1 year. What if I wanted interest after n years? Well, now we can define a year variable n, which represents the number of years. And we can raise 1 plus r to the nth power. So we multiply the principal by the rate n times. And then this is just simply our formula for interest with yearly compounding. Now, what if we wanted to do monthly compounding? Similarly, we start with the principal amount. And we have to multiply by the interest rate. But note that here, it is not 1 plus r anymore, because you would have to divide by r by 12. Why? Well, we can look back at this example. We had an interest rate of 10% per annum. But when we do monthly compounding, we have to first calculate the monthly rate first. How do we calculate the monthly rate? Well, we assume that the rate is distributed evenly. So we divide r by 12 because there are 12 months in a year. And then again, we raise this to n power. But note that n is the number of years. So if we just do this, what this would mean is in 1 year, we would only multiply p by the monthly rate once. But this is not the case. We have to multiply it 12 times, right? That's where the compounding comes in. So we have to define, so in here, we have to multiply n by 12. And this gives us the equation of the formula for monthly compound interest. Interest that is compounded monthly. Well, what if now we say that interest is compounded t times a year? So number of times compounded per year. What would the formula be for this? Again, we would start with our principal amount. And this time we would still multiply by the rate. But this time the rate is 1 plus r over t. Why over t? Because t is the number of times compounded per year. So we assume that the interest is divided evenly. Therefore, we have to divide this by t. And then we have to raise this to the nth power. But not only to the n power, we have to raise this to the n multiplied by the t power. Because it is compounded t times every year. And this is our general formula for compound interest. Right? If p is the principal amount or the starting amount, if r is the interest rate per year, if n is the number of years and if t is the number of times compounded per year, this is going to be our compound interest formula for any p, r, n, and t. But now, if you love math, you might think of something niche. What if the compound was continuous? What if my bank just compounded my money every second, every millisecond, every single moment of my life? What if the compounding just never stopped? It just kept going. What if the compound was continuous? Well, if the compound was continuous, we'd have to define E, which is known as Euler's constant. This is a very, very, very important constant within mathematics. And it has a lot of applications, not only in compound interest, but also in complex numbers. And when you learn calculus, it also has a lot of applications in calculus. Not to get overly nerdy, if we have, right, e to the x, the derivative of e to the x is just e to the x. It is a self-derivative, but not to get too nerdy here. All right, so what does e have to do with compound interest? Consider this scenario. What if you have $1 and you invest it in a bank that gives you 100% interest? And it gives you that interest continuously. After 1 year, we would amount to a value of e. We can break this down a little. What if we have the bank that gave you $1 that with the principal of $1 and 100% interest? compounded yearly? Well, this would just be $2, right? What if this 100% was compounded monthly? Well, this would be something like $2.6 to $2.7. Sorry, I haven't done the calculations. It's just like a rough estimate. What if this was compounded weekly? Well, it would be something like 2.71. And if this was compounded continuously, we would get E. And through our compound interest formula, what would E be equal to? Well, E would be equal to our principal amount, which is 1, multiplied by 1 plus R over T. But in this case, what is R? R is just 1, 100%, right? 1 over infinity to the infinite power. Because in here, it is compounded infinite times within a year. And in limit notation, we can write this as E is equal to 1 times 1 plus 1 over n to the nth power, where n approaches infinity. Right, the limit of 1 plus 1 over n to the nth power as n approaches infinity. And this is a brief introduction into Euler's constant. Alright, so in this video, we talked about compound interest. We talked about the formula for compound interest and where it was derived. And we also talked about Euler's constant. If you like this video, please like, subscribe, and comment. And here's a big surprise coming for y'all subscribers. There is a 100 subscriber special that is coming out. It will involve me doing 100 SAT problems. Yes, you heard that right. 100 SAT problems. So if you like this channel, please subscribe so I can make that 100 subscriber special video. Thank you.